Good morning, everybody. We continue function, definition of function. Yesterday, we were talking about the notation for function. Y equals f of x. Function can also be described as an equation. An equation which connects variable x and variable y. For any given value of variable x, there's only one value for y. Then the equation gives us a function. So for example, yesterday we see y equals x plus 1. We agree this function is a linear function, right? This equation gives us a linear function. The output of the function always equals input plus 1. If I replace y with f of x, then the equation becomes f of x equals x plus 1. Yeah, so we want to understand this notation. When you see f of x equals x plus 1, that equation gives us a function. Yeah, that equation gives us a function. How do you understand f of x? Remember, f of x is just y. F of x is just y. In other words, f of x is the output of function f as the input is x. Yeah, we are understanding the notation f of x. What is f of x? F of x is just y. We know y represents output, right? Yeah, f of x represents the output of the function. We use the function is f. If the letter f here, if the letter is f here, then f represents the function. F of x is the output of the function f as the input is x. Okay? Yeah, so let's look at this function f of x equals x plus 1. Yesterday we agreed this is a function. It's the linear function. It represents a straight line, slanted straight line in a rectangular coordinate system, right? Okay. So what if I need you to find f of 1? How do you understand the notation f of 1? And how do you evaluate f of 1? Yes. Firstly, we need to understand what is f of 1. What is f of 1? Let's recall the notation f of x. F of x, as I wrote here, f of x refers to the output of the function when the input is x. Knowing whatever inside the parentheses, that's the input. That's the element in the domain. That's the input. If f of x represents the output of the function as the input is x, then f of 1 would represent the output of the function as input is 1, right? Let me write it down. F of 1 here represents the output of the function as the input is 1. Do you guys agree? Yes? Okay, then how should we find the output of the function for the input 1? Remember, this is a machine, right? The function is a machine. Now we need to find the output as the input is 1. Let's look at the function. Function f of x equals x plus 1. In other words, y equals x plus 1. The output is always equal to the input plus 1, right? So if the input is 1, what is the output? we are looking at this function, f of x equals x plus 1. It's a straight line. If the input is 1, what's the corresponding output? Still 1? Okay, this function, the pattern of this function or this machine always produce output equals input plus 1. Do you see that? Yeah, because y equals x plus 1, right? Yeah, the function actually is just y equals x plus 1. X is the input, y is the output. For this function, for this machine, all the corresponding output equals the input plus 1, right? When the input is number 1, what is the output? 2. Awesome, exactly. You guys see that? Exactly, very good. Yeah, when the output is 1, the input is 1, the output is 1 plus 1 equals 2. Awesome. Tell me what is f of 0? 0 plus 1, right? So you can see simply you just plug in. Yeah, when you look for f of 1, just plug in x equals 1. When you look for f of 0, just plug in x equals 0, right? And what is f of negative 1? Perfect. What is f of t? What is it? T plus 1, right? Did you say t plus 1? U? We don't have u. So if the input is t, remember the output is always equal to the input plus number 1, right? This case, in this time, t is input is t, then what's the output? When the input is t, what's the output? Okay, when the input is x, look at the green. When the input is x, output is x plus 1. When the input is 1, output is 1 plus 1. As input is 0, output is 0 plus 1. As input is negative 1, output is negative 1 plus 1. What's the output when the input is t? Here, t plus 1. T plus 1, yes, t plus 1. Because the output always equal to input plus 1, right? Sarah, do you see that? Yes? Angela, do you see that? When the input is whatever, the output is also the whatever plus 1. In this case, input is t, so corresponding output is t plus 1, right? Okay, then what is f of star? Star plus 1. What is f of triangle? Triangle plus 1, exactly. Perfect. That is a function. Function is a relation. For any given input, there's only one corresponding output. This function f, the output always equal to input plus 1, right? Yes? All right, so what if I'm going to give you a different function? This time I use g. Yeah, so look at the notation. F of x, g of x, even I use h of x. When you work on my lab math assignment, you maybe see some other letters, maybe w of x. Yeah, so those are all notations for function, just different letter. Earlier we have f of x. We assign f of x as x plus 1. Here we're gonna have another function, g of x. What is g of x? G of x is x squared minus 1. Do you guys remember example 5, the parabola? That's the function, right? Yeah. G of x is x squared minus 1. Okay, how do we understand the notation g of x? How do we understand the notation g of x? What is g of x? What is g of x? G of x is just the y. Okay, it's just the y. So the function is given by this equation, y equals x squared equals 1. It means the output of this function is always equal to input to the power of 2 minus 1. Do you agree? Every function is different, right? How does the dependent variable y depend on independent variable x is different for every function. In this function, independent variable is x, dependent variable is y, right? Value of y depends on value of x. Value of y always equal to square of value of x minus 1. Here, x is the input, y is the output. So the pattern for this function g, output is always equal to square of input minus 1. So g of x here means the output of function g as the input is x. All right? So once again, let me see if you really understand it. And tell me, what is g of 1? What is g of 1? What does g of 1, this notation, represent? What does g of 1 mean? If we know g of x is the output of g as input is x, then what is g of 1? Huh? Means the output as well, right? G of 1 means the output of a function g as the input equals what? Remember, whatever inside the parentheses, that's the input. When the input is what? Yeah. Do you guys agree? G of x, the notation. Lauren, do you have any question? G of x represents the output of function g as the input is x. Then g of 1 would represent the output of g as the input is 1, right? Yeah? Okay, now you understand the meaning of the notation. Can you find the value for the notation for g of 1? How do you evaluate g of 1? What is the output of this machine when the input is 1? Yeah, what does this machine do? It produces output always equal to square of input and minus 1, right? Can anyone figure out the value of g of 1? Yeah, what did we do earlier? Simply say just plug in, right? Yeah, can you just plug in? Sammy, what is it? Huh? We don't have t here. We do not have t. G plus 1. I don't understand what is that. G of x. Okay, look at it here. G of x is x squared minus 1, right? G of x is x squared minus 1. We are looking for g of 1. The place of x is 1. So could we just plug in x equals 1 to get the value? If we plug in x equals 1, what is it? 1 squared minus 1 is 0, right? Do you see that? Okay, again, function g produce output always equal to square of input and then minus 1, right? That's the function g. That's how does y depend on x. Okay, so we are looking for the output of the function for the input 1. Remember, output always equal to square of input minus 1, right? So the output would be square of input minus 1, that is 0. Does that make sense? So you can simply just plug in x equals 1. Sammy, is that clear? Then can you help me to find out g of 2? What is g of 2? Yeah, we are understanding the notation. 2 squared minus 1, exactly. G of 2 is the output of the machine as the input is 2, right? Whatever inside the parentheses, that's the input. Am I clear? Yeah, whatever inside the parentheses, that's the input. This time the input is 2. Yeah, this machine always produces output equal to square of input minus 1. So the output would be 2 squared minus 1. And what is it? Okay? And What is g of 3? Three square minus 1? Yes? Awesome, exactly. And what is g of t? Tell me what is g of t? Yeah, now we have t. Now the input is t. And what is it? Input is t. And output always square of input minus 1. T square minus 1. It's easy, right? All you do is to replace x with whatever the input is. And what is f of star? Star square minus 1. G of triangle. Triangle square minus 1, right? What if I said g of whatever that is the green part? It's always the input. The input, I don't know what is the input. It's just the input square and then minus 1. Do you see that? Yeah. We understand function as a machine helps us to evaluate the function at a given input. So the whole thing, the point is you understand the notation. You understand the notation f of x. F of x is just y, okay? It represents the output of the function as the input is x, whatever the input is. Yeah? That's a good question. The reason I use f of x here and use g of x here is to show you those two functions are two different functions. That would be weird if I use f to represent this function and use f to represent different function, right? They are just two different functions. That's a good question. Yeah, you're right. The letter doesn't matter. But once you assign the letter for a specific function, you have to keep that consistent. You don't change it in the middle. So the whole time, the only point here, you need to understand what is f of x. You need to understand those notations. You need to understand f of x. If f of x is x plus 1, that function is a linear function. That machine produces output equals input plus 1, right? Then you need to understand what is f of 1, f of 2, f of 0, f of t, f of star. Those are outputs for given input, and the given input is in the parentheses, right? Okay, same with g. Once we assign this function as g, we know g represents this machine, produce output always equal to square of input minus 1, right? And you need to understand what does those notation mean. Those notations mean the output for the given input inside the parentheses. Am I clear? Okay, so that will be the last part of this 3.7. Now we are ready to review for test 3, which takes place tomorrow. Let's start a review. Test 3, we are going to have how many questions? 23. 20. Test 3, we're gonna have 26 questions. Okay. Test 3, we're gonna have 26 questions. Let's see the first problem. All the questions are multiple choice questions. Number 1, decide whether or not the ordered pair is a solution of the equation. Okay, the equation is x minus y equals 7. The equation is x minus y equals 7. The given point is 1, 8. Please determine if 1, 8 is a solution of the equation x minus y equals 7. How do you determine that? How do you determine that? This is the equation. This is the linear equation in two variables. And we have an ordered number pair 1, 8. You want to determine if this point, if this ordered number pair is solution of the given equation. How do you determine? Plug in. Awesome. Exactly. Okay, you plug in and let me know what you have. You plug in x equals 1, y equals 8, right? Let's see if we have a true statement. Then yes, it is a solution. If we got a contradiction, then it's not a solution, right? X minus y equals 7. What's inside the first parenthesis? What is x? What is y? What is 1 minus 8? Is -7 equals 7? True or false? False. So is this ordered pair a solution or not? Not a solution, okay? Just choose no. Just choose no. Does that make sense? It's easy, right? Any question about this problem? Tomorrow, the first problem, you simply just plug in. X equals the first component, y equals the second component. If after you plug in the equation, you got a true statement, you choose yes. If you got a contradiction, you choose no. Is that clear? Okay, let's see number 2. Do you guys mind I just erase those once you guys finish the writing? When you copy them on your note, could I erase it? Okay. Number 2. Number 2, you need to decide. You're gonna do the same thing, okay? Actually, decide whether or not the ordered pair is solution of the equation. Okay. So number 2 and number 1 is the same thing. Different equation, different ordered pairs. So this equation is 3x minus 2y equals 10. The given ordered pair is 2, -2. Okay, please plug in. So tomorrow, the first 2 problems are to determine if the given ordered number pair is solution of the given equation or not. You simply just plug in. You plug in this time x equals 2, y equals -2. Be careful with the sign. And what you have? 3 times x minus 2 times y equals 10. What should I put in the first parenthesis, Ian? What should I put in the first parenthesis? 2, yeah. What should I put in the second parenthesis? -2, very good. What is 3 times 2? What is -2 times -2? +4 or -4? +4, okay. Do you have a true statement or contradiction? True. If you got a true statement, then you choose yes. Is that doable? Doable, the first 2 problems? Very easy, right? I guess the actual problems tomorrow, the 2 problems, one is yes, the other is no. Any questions? Number 3. Number 3, you will also be given an equation. The equation is y equals -2x plus 3. And you are given an ordered pairs whose x coordinate is known, whose y coordinate is unknown. You need to look for the y coordinate. Yeah, let me explain what happened to this problem. You are given a straight line, right? Y equals -2x plus 3 is a linear equation, 2 variables. This actually is a slope intercept form. You know this point is on the line. Well, this ordered number pair is the solution of the equation. You know the x coordinate is 5. You need to find the corresponding y coordinate. Yeah, how do you do that? You need to find the corresponding y coordinate. What's the idea? You have the value for x. You have the value for x, right? Would you just plug in x equals 5? Would you just plug in x equals 5? This is x, this is y. You know the value of x. You need to look for the value of y. Would you just plug in x equals 5? Okay, please do that. Tell me what is y. -7? Awesome. Yeah. So Ian, should I put what should I put in the parentheses? X was there in the equation. What should I put in the parentheses? 5. What is -2 times 5? -2 times 5. Tell me, is it positive or negative? Negative what? 10. What's -10 plus 3? -7. Okay. So you are choosing -7, okay? You are choosing -7. So you look at ACD, you are looking for 5 comma -7. Am I clear about number 3? For number 1, number 2, you need to decide if the given ordered number pair is solution of the equation. You just plug in. True statement, choose yes. False statement, choose no. Number 3, this problem, you plug in the given x value, look for the corresponding y value. That's it. Let's see number 4. Number 4 this time, similar but it's different. Number 4, you are given an equation, and you know a ordered number pair, something -26 is a solution of the equation. You need to find the corresponding x value. So what happened is this time you are given y value. You need to find the corresponding x value. The equation is 7x plus y equals -26. Same with earlier. Number 3, you are given value of x. You look for the value of y. In number 4, you know the value of y. You are looking for value of x. So what should we do? Should we plug in what? Y equals -26, right? Okay, let me know what you have for x. Let me know what you have for x. You plug in y equals -26. You're going to solve the equation for x. And let me know what you have for x. What is x? 0? Exactly. As did you see, you have -26 on both sides. If you have the same number on both sides, you can get rid of them at once. Then you have 7x on the left, 0 on the right. You divide both sides by 7. You have x equals 0. So the answer you are looking for is 0 comma -26. All right, so that's number 4. Number 3 and number 4, same type of problem. Number 3, you plug in x, you find a y. Number 4, you plug in y, you find x. Any questions? Let's see number 5. Number 5. Number 5 and number 6 are similar. Number 5. Number 5 and number 6 are about rectangular coordinate system. Number 5, you are given 2 points. You need to find their corresponding ordered number pairs. Number 6, you are given 2 ordered number pairs. You need to find their corresponding points. You see what I'm talking about here? And number 5, you are given 2 points in the rectangular coordinate system. You need to identify their coordinates. And number 6 is the opposite. You're given 2 ordered number pair. You need to plot them in the rectangular coordinate system. Yeah, those 2 problems are kind of like together about the same topic. All right, let's see. Let's see number 5. Point A. Can you identify the coordinates for point A? Where is point A? Quadrant 1 or quadrant 2 or 3 or 4? Point A. Where is point A? Is not on any quadrant, right? It's not in any quadrant. Is it on the x-axis? What's the coordinates of this point? A. It is 1, 2, 3, 4, 5, 6. 6 units to the left of the orange. So what is it? Comma 0. Awesome. You know, I expect you guys have a very good score for tomorrow. Those are very basic. Yeah, I don't challenge you. Those are very basic things. What about B? Point B, which quadrant? Quadrant 4, yeah. So X supposed to be positive, Y supposed to be negative, right? And you can count. I think it's 3 units to the right, 1, 2, 3, 4. 4 units below. So what is it? 3, comma 94. Awesome. Perfect. Yeah, don't lose point on this. Is that clear, Sammy? Number 5. Okay, cool. Number 6 is the opposite. You are given 2 ordered number pair, A and B. You need to plot the 2 points. Yeah, A is 4, comma 6. Both X and Y are positive. So quadrant 1, 2, 3, or 4. Which quadrant? A, 4, comma 6. Quadrant 1, yeah. Quadrant 1 is to the right and the top, right? Right top corner. Quadrant 1. So it's 4 units to the right or 4 units above. X coordinate describes the horizontal displacement, right? So 4 units to the right, 6 units above. Make sure you know where should you find the point. It's here, okay? 4 units to the right, 6 units above. And now let's see point B. X, -4, Y is 3. Which quadrant? 2, quadrant 2. So 4 units to the left, 3 units above, right? Like that. Do you think you can get this problem right tomorrow? Yes? Oh, yes, still multiple choice question. You will be given 4 graphs. Okay. Yeah, you just need to choose the one. Yeah, have the correct 2 points. Number 7. Use the coordinates of the indicated points to find the slope of the line. Okay. So number 7, you need to find the slope of the given line. And the given line is very special. What kind of straight line, the given straight line? Oblique, horizontal, or vertical? Number 7, what's special about the horizontal? What's special about this straight line? Horizontal, okay. Do you guys remember what's the slope of a horizontal straight line? 0, okay? Yeah, so number 7, if you see the line is horizontal, is flat, slope is 0, number 0. What if in number 7 tomorrow, the given line is vertical? Then what's the slope? Undefined. The only correct way to describe the slope of a vertical line is undefined, okay? Undefined. Number 8, let's see, number 8. Number 7 on the review is 0 because the line is horizontal. But tomorrow, maybe, I don't remember exactly, maybe on the test, number 7 is a vertical line. So if you see a vertical line, you choose an undefined. But in the review, if you see a horizontal line, you choose 0. Depends on what line do you see tomorrow, okay? Let's see number 8. Number 8 is kind of like a lot of work. Let's see number 8. The problem is below. Number 8, you are given a straight line, 2x plus y equal to 6. And you are given 3 points on the line. They are 0, comma, whatever, comma 0 and 4, comma something. Yeah, so you have the first point, y coordinate unknown. Second point is the x coordinate unknown. Third point, the y coordinate is unknown. You need to complete the 3 ordered number pairs such that those 3 points are on the line. And then you graph the straight line. So a lot of work for this problem. So number 3, number 4 earlier are about the same thing, right? You're given one coordinate. You need to find the corresponding the other coordinate. Let's see, how do we find the blue? How do we find the blue? Plug in x equals, perfect, please do so. Yeah, please plug in x equals 0. When you plug in x equals 0, what is y? 6, awesome, exactly. Perfect. All right, let's see, how do we find the green? How do we find the green? Plug in y equals what? 0, awesome, please do so. Yeah, we probably need to hurry up in order to finish the review today. And what is x? 3, perfect. This, the purple, should we plug in x equals 4? Tell me what is y? -2, awesome. And then you plot those 3 points. Where is 0, 6? Where is 0, 6? 1, 2, 3, 1, 2, 3, 3 units above the orange, right? Where is the 3, 0? It's right here, right? Where is the -2? In quadrant 4. So you have those 3 points, you connect them, you would have the straight line. Okay, that's number 8. Let's move to number 9. Let's move to number 9. Find the intercepts for the straight line. Find the intercepts for the straight line. Intercepts. 2 intercepts, right? Okay, do you guys remember how do we find the x-intercept and the y-intercept? The line is x minus 3y equals 12. Equals 12. To find the x-intercept, should we make y be 0? Make y be 0. We get x equals what? Remember, if the equation is in the standard form, finding the intercept is very convenient. As y equals 0, what is x? 12. Yeah, exactly. So the x-intercept is 12, 0. Okay? In order to find the y-intercept, we make x be 0. We make x be 0. And we find y equals what? If we make x be 0 this time, we make x be 0, we have negative 3y equals 12. And what is y? Coefficient of y is negative 3. How do we find the y? Negative 4? How do you get negative 4? You divide both sides by negative 3, right? Does that make sense? Sorry, do you see that? Yeah. Yeah. So if you have negative 3y equals 12, you divide both sides by negative 3. 12 divided by negative 3 gives you negative 4, right? So 0, negative 4 is the y-intercept. Number 9, you need to know how to find the two intercepts for any given equation, linear equation in two variables. Yeah, so for the details right here, you plug in y equals 0 to find the x-intercept. Plug in x equals 0 to find the y-intercept. Number 10. Number 10, true or false? The y-coordinate is negative in quadrants 3 and 4. Is the statement true or false? Y-coordinate, it describes the vertical displacement, right? Y-coordinate is negative. Negative means it's below the origin, right? The y-coordinate is negative in quadrants 3 and 4. Is that true or false? True. Okay, y-coordinate is negative means the point is below the origin. Points in quadrant 3 and 4, they are below the origin. So quadrant 1, both x and y positive. Quadrant 3, both x and y negative. Quadrant 2, x is negative, y is positive. Quadrant 4, x is a positive, y is a negative. Any questions? If you need it, I can give you tomorrow. Okay. Number 11, find the intercepts. Find the intercepts for 3x minus y equals 3. Find the intercepts for the graph of the equation 3x minus y equals 3. All right, let's see, how do we find the intercepts? We did something similar earlier, right? Yeah. How about let's find the x-intercept first. Let's make y be 0. Let's make y be 0. What is x? Make y be 0. Make y be 0. What is x? Make y be 0. What is x? 3, hold on. Make y be 0. You have 3x equals 3. 3x is 3. 1. Do you see that? Yeah. So x is 1. You see how convenient it is? That's x-intercept. For y-intercept, you plug in x equals 0. Okay. Let's plug in x equals 0 for y-coordinate. If x is 0, what is y? -3, yeah. If -1 is 3, y is -3, right? So 0, comma -3, y-intercept. All right? Number 12, find the slope for this straight line. What kind of straight line that is? Vertical, right? What's the slope of this straight line? Huh? 0? Not 0, okay? Undefined. Again, when you see the lines horizontal, slope is 0. When you see the lines vertical, slope is undefined. Number 13. Okay, yeah, this is number 13. Number 13 is you're gonna look at the graph and find the slope for the line. Yeah, you're gonna look at the graph and find the slope for the line. Okay, look at the line. Is it going up or going down? Go up. So if you look at A, B, C, D, would you choose a negative number? Of course, please don't. Yeah, if you see the lines going up, means the slope is positive, right? You, of course, will not choose a negative number. What positive number? We can try to use for number 13 tomorrow. Try to use this concept. Try to use the slope equals rise over run. Try to use the slope equals rise over run. Do you see the 2 points in black? Yeah, so let's go from A to B. Yeah, if this is A, this is B. So what is the rise? What is the run? We go from this point, A to B. How much do we go up? 1, 2, 3, 4. Yeah, so the rise is a +4, right? And the run is horizontal. From A to B, how much do we go to the right? From A to B, how much? 3. Yeah, so what's the slope? 4/3, right? So number 13 tomorrow, the easy way. Number 13 tomorrow, the easy way. I start to feel like this is so not convenient. So number 13 tomorrow, try to use the concept of slope equals rise over run. Is easier, okay? I can give you a hint tomorrow if you need help. Any questions? Number 14. Number 14 is easy. Is the slope of the line positive, negative, 0, or undefined? Negative. Okay, please don't get it wrong for this one. If the line going up, positive. Going down, like this one, negative. Horizontal, 0. Vertical, undefined. 15. 15. Yeah. 15. Yeah, you know, I have solution in my note. I wanna cover it. Then you can try on your own first. We have 2 given points on a straight line. You need to find the slope of the line. Yeah, so number 15. Find the slope of the line going through the given pair of points. 2, 3, -1, 0. What formula are you going to apply? This formula. Yeah, I'll tell you, number 15, if you don't know how to start, I'll tell you, okay, number 15, you use this formula. We have 3 steps to apply the formula to find the slope, right? Remember, firstly, I always label the 2 points, x1. Let me see if I can make this thinner. x1, y1, x2, y2. So you have x1, y1, x2, y2. Tell me, please, what's x1? What's x1? What's y1? What is x2? y2 is 0, right? Okay, that's first step. Step 2, copy the formula, which is on the board. Y sub 2 minus Y sub 1 all over X sub 2 minus X sub 1. And then you're gonna please use the parentheses to frame those 4 values. What's gonna be inside the first parenthesis? Y sub 2. What's Y sub 2? What is Y sub 1? Y sub 1. Yeah, so be very careful. The reason I would recommend you write that is to make sure you plug in the right numbers. Denominator, what is X sub 2? -1. What is X sub 1? 2, okay. Tell me please, what is 0 minus 3? -2, right? And what is -1 minus 2? -1 minus 2. Use your calculator, please. The good news is for only the first test, you don't use calculator. What is -1 minus 2? Ian? Yeah, -1 minus 2. -3. If numerator is negative, denominator is negative as well. The quotient is positive or negative. Both top and bottom are negative. Yeah, positive. The quotient is positive. 2/3, okay? Let me double check. Did I plug in anything? 0 minus 3, -1 minus 2. Oh, my bad. Yeah, you're right. Sorry about that. Yeah, 0 minus 3 is -3. How did I write -2? So 3 over 3 is 1, right? Slope is 1. Sorry about that. 0 minus 3 is -3. Numerator is -3. So if the numerator and the denominator are identical, the quotient is 1. All right? Okay. Number 16. Number 16. Number 16 is easy. Number 16, you need to find the slope of the given line. Find the slope of the given line. The line is y equals -x plus 9. What's the slope? What form the equation is in? We have 3 forms. Standard form, slope-intercept form, point-slope form. What about this one? Yes, slope-intercept form. M is the slope, right? M is the coefficient of x on the right-hand side of the equation. Tell me, what's the coefficient of x on the right-hand side of the equation? Number 16. You are looking at the number 16. Yes. I highlighted in green, right? Is that easy? Super doable, right? It's simply just a direct application of the formula. Yeah, how do you identify slope from slope-intercept form? It's very easy. Number 17. Okay, 17, 18, 17, 18, 19. They are the same. 17, 18, 19. They are same type of problem. 17, 18, 19. Same type of problem. You are given a pair of straight lines. You need to determine, are they parallel, perpendicular, or neither? You might still remember we just learned that part a while ago, right? Yeah, you are given 2 straight lines. You need to determine, are they parallel or perpendicular or neither? Let's look at 17. We have 2 straight lines, blue and green. Are they both in standard form? Okay. Remember, if the equation is in the standard form, we can use this formula to find the slope, right? Okay. So let's see the blue one. The blue one. 3x minus 4y equals 12. Tell me what is A, what is B? A, B, B. Yeah, okay. A over B. What's A over B? 3 in the numerator, -4 in the denominator. Am I right? -3/4? Yes? And slope is the opposite of A over B. What's the opposite of -3/4? +3/4. Okay, very good. That's the slope of the blue. Let's look at the slope of the green. The green equation is 4x plus 3y equals 12. Tell me please what is A and B? 4, 3, A over B is 4 over 3, right? What's the opposite of A over B? What's the opposite of 4 over 3? -4 over 3. Okay, very good. Let's look at the blue slope and the green slope. Are they the same? No, of course you do not choose a parallel, right? Do they multiply to -1? Oh my gosh. Do they multiply to -1? Are they negative opposite of each other? Oh, sorry, negative reciprocal of each other. They multiply to -1, right? Yeah, so you should choose a perpendicular. All right? You should choose a perpendicular for this one. You don't graph. You determine are they parallel or perpendicular or neither from the values of their slopes. If they have the same slope, if their slopes are identical, you choose parallel. If their slopes multiply to -1, in this case, 3 over 4, -4 over 3 multiply to -1, right? Then you choose perpendicular. That's the theorem. And neither. If they are not equal to each other, if they are not negative reciprocal either, then you choose neither, right? Am I clear? You have 3 problems. Number 18. I'm gonna give you 1 minute. Why give you 1 minute? Because we are running out of time and we have to finish all the review. I give you 1 minute to help me to find the slope for the 2 straight lines. Can you do that? Help me to find the slope for the blue. Find the A and B. What's the slope of blue, Vanessa? Yeah, work on it on your paper. Will be faster sometimes. What's the slope of the blue? -2/3, right? Right? You can see that's 3, yeah. A is 2, B is 3. Negative A over B is -2/3, right? Yeah, what about the slope of the green? Get a pen, please. What's the slope of the green? Yeah, what is it? -4 over 6. What is 4 over 6? 4, 6. 2/3. Are they the same? Parallel. You choose parallel, okay? Questions? Okay. Next up, please find the slopes for those 2 straight lines, blue and green. Knowing the blue equation is in the slope-intercept forms, right? The blue is in the slope-intercept form. Could you identify its slope right away? Bless you. What's the slope of the blue? What's the slope of the blue? Y equals 2x plus 10. This straight line is in the slope-intercept form. What is M? Slope. 2. Yes, slope of the blue is 2. Can you find the slope for the green? Green is in the standard form. You have to use the formula. Find the A, find the B. Find the negative A over B. Tell me, what is it? Ian, what's the slope of the green? 3. What is A? 6. What is B? What is A or B? Huh? What is A or B? 6 over 3. What is it? It's 2, right? And the slope is negative A over B. So it's -2. So the two slopes are opposite. Should you choose parallel or perpendicular or neither? Huh? For this case, number 19, what should you choose? Parallel? Perpendicular? Neither. You choose neither. Okay? They are not a parallel. They are not a perpendicular either. They are neither. So those are 3 problems, 17, 18, 19. Any questions? Any questions? 17. Oh, 17 is perpendicular. But tomorrow 17 might not be perpendicular. You have to work on it. You have to find your slopes. The 3, I could only tell you tomorrow the 3 problems, 17, 18, 19. One of them is parallel, one of them is perpendicular, one of them is neither. But I don't know which one is which one. Okay? Any questions? Sarah, any questions? Let's see. We move to 20. Okay, let's see. Okay. So choose the line that most closely resembles the graph of the given equation y equals 3x minus 4. Okay. So number 20, you are graphing a straight line. You are graphing a straight line, y equals 3x minus 4. Can you do that? Yes. You're graphing y equals 3x minus 4. What form this equation is in? Standard form, point slope form, or slope intercept form? Slope intercept form. Very good. So what's the slope? What's the intercept? Y-intercept. Yeah, 0, -4, right? Very good. Slope is 3. Y-intercept is 0, -4. So for number 20, you will be given A, B, C, D 4 graphs. You need to choose the correct straight line corresponds to the equation y equals 3x minus 4. If you see a line going down, would you choose that? Of course you don't, okay? Yeah, obviously the slope is, oh my gosh, it's happened again. The slope is 3 is positive, so the line you are choosing has to goes up. Okay, the line must be going up. More specific, you plot 0, 94, the y-intercept. Since the slope is 3 over 1, slope is 3 over 1. Slope, rise over run, is 3 over 1. Your rise is 3, rise 1. So you start from the y-intercept. You go up 3, go to the right 1, and you have this point. You do the same thing, go up 3 to the right 1, go up 3 to the right 1. And you have enough, when you have enough points, you connect them, you have the straight line, okay? By the way, if you see a straight line which does not go through 0, 94 at all, would you choose that? Yes or no? No, of course, right? So you can use those properties to eliminate some answer choices to narrow down the correct answer. Any question about number 20? Number 20, Angela, do you have any questions? So firstly, you are not choosing a line going down. right? You have to choose the line going up. Secondly, the line you are choosing has to pass through 0, 94 because that's the y-intercept, right? Say again. The reason, oh, that's a good question. The reason you need to choose a line going up for this Reviw problem is because the slope is 3, is positive. Maybe tomorrow, number 20, the slope is negative. So please do not choose a line going up. You have to make the decision based on the slope. Yeah, I don't remember tomorrow. Maybe it's slope positive, maybe it's negative. Okay? Number 21. Identify the slope and the y-intercept. Okay, this one is easy. The equation is y equals negative x plus 4. Y equals negative x plus 4. Tell me what's the slope? What's the y-intercept? Is that doable? Yeah, just the definition of a slope intercept form. Very straightforward. Number 22. Oh my God, this one is a lot of work. We need to graph this equation. Oh no, we need to graph this inequality. Linear inequality in 2 variables. We did this maybe on Monday, I think, right? Graph linear inequality in 2 variables. I give you 2 steps. Do you guys remember? 2 steps. Yeah. Firstly, do you guys remember what's the first step? Sammy, do you remember the first step? When you graph a linear inequality in 2 variables. Yeah. You change the inequality symbol to equal sign. That's the boundary line, right? You see that? And we need to graph the boundary line. So how do we graph it? You can find a different method to graph it. The way I'm going to do that is I make y be 0. If I make y be 0, I see x equals 95. If I make x be 0, I see y equals 5. Let me show you quickly. Since this equation is in the standard form, I'm going to find the x-intercept and y-intercept in order to graph it. From the x-intercept, I make y be 0. See that? Make y be 0. So x is 95, right? For y-intercept, I make x be 0. When I have x be 0, negative y is 95, of course y is 5, right? Once I have 2 different points on the line, I can plot them and draw the boundary. 95, 0 is right here. 0, 5 is right here. Okay. Am I supposed to graph the boundary solid or dashed? Solid. Awesome. You guys still remember that. It's awesome. Okay. Do you guys remember what's the second step? What's the second step? Testing point. Can we use 0, 0 in this case? Yes, because 0, 0, the red point is not on the boundary, right? We're going to plug in x equals 0, y equals 0 into the original inequality. Let's see what we have. 0 minus 0. 0 is less than or equal to 95. True or false? 0 is less than or equal to negative 5. True or false? Yeah, you're right, false. 0. 0 is better than 95. I mean, you have nothing is better than your own people or something, right? So this is false. This is false. So should we shade the region above or below? Above, yeah. If the testing point is not a solution, you shade the region without it. Okay? Number 23. Yeah, I will post the Reviw today in Moodle. I have all the steps clearly in my note in detail. You can study them for tomorrow. Yeah. So if the testing point is not a solution, you shade the region without it because it's not a solution, right? Suppose the testing point is a solution, then you shade the region with it, containing it. Okay. Number 23. Number 23, let's see, determine function or not. Determine is number is relation or function or not. Do you see the set? Do you see the set? How many pairs in the set? 4 pairs, right? Okay, that's a relation. Determine is if this relation a function. Why not? Yeah. Remember, if the person has 2 different biological mothers, that's not a human being, right? So for the same x, if you have 2 different y's, then the relation is not a function. This machine have 2 different outputs for the input 1. Look at it here. Those 2 pairs have the same x, different y, right? Not a function. This should be still fresh. We just did it. Today is Thursday. I think we did this on Tuesday, right? We learned this on Tuesday. It's not a function. Is that clear, everybody? Number 24. Okay, determine function or not. Determine function or not. Is this a graph? Is this a graph? We have a very convenient technique to determine if a graph a function. What's the technique? Vertical line test. So apply vertical line test. Tell me, is this parabola? This parabola is open to the right. Yeah. Determine if that a function or not. No, it's not a function, right? Because you will see a vertical line passes the graph more than once. Those 2 points, they have the same x, different y, so it's not a function. All right, vertical line test is for 24. Vertical line test. Okay, number 25 is very straightforward. Number 25 is very straightforward. You have f of x equals negative 3x plus 5, negative 3x plus 5. Find the f of 5. The beginning of today, we will practice, we were covering this part, right? We have f of x equals negative 3x plus 5. We are looking for f of 5. F of x is the output of the function, as the input is x. This function tells us the output is always equal to negative 3 times the input plus 5. F of 5 represents the output of the function, and the input is what? 5. So the output is supposed to be negative 3 times the input plus 5, right? Or more, simply say, just the plug in, right? Make it simple, just the plug in. Plug in equals 5. Plug in x equals 5 and tell me what you have. Plug in x equals 5. Tell me what you have. Negative 10. Yes. So the answer is negative 10. Okay? You're going to choose negative 10. Any questions? Number 26, the last one. We have 1 minute. Suppose that, suppose that sales of a particular brand of appliance satisfy the relationship y equals 130x plus 4800, where y represents the number of sales in year x with x equals 0 corresponding to 1992. Find the number of sales in 2000. So let's think about if as x equals 0, the year is 1992. As x equals 1, the year is 1993, right? When x equals 2, 1994, x equals 3, 1995, x equals 4, and so on. As x equals what? The year is 2000. As x equals what? The year is 2000. Is 8, right? So you plug in x equals 8 in the equation to find the corresponding y value. Yeah, I know it's too fast. So tomorrow I will give you a hint on the board for the last application problem. All right. So we run out of time. Thank you guys for coming. I'll see you tomorrow.